Dear students, today we are going to talk about a law which is known as Marie Ampere's law. This law was derived empirically, which tells us that what is the force acting on a current carrying conductor when it is placed in some magnetic field. You can very well understand that therefore there has to be some force acting on the conductor only because the charge is moving through the conductor, electric current is flowing through it, therefore charge is moving through the conductor, and since the charge is moving through the conductor and exists some magnetic field, so naturally this magnetic field will apply some force on the moving charge according to the Lorentz force, and so some force will be acting on the charge, and since the charge is within the conductor, it is not outside it, so if the charge is experiencing some force, conductor will also experience same force. So this is the reason there should be some force acting on a conductor. Now here you see the Marie Ampere law was derived empirically. What they found is they found that the force acting on the conductor is directly proportional to the current. Force acting on the conductor is directly proportional to the length of the conductor. Force acting on the conductor is directly proportional to the magnetic field present over there, and force acting on the conductor is also directly proportional to sine of the angle between the conductor and the magnetic field. When you add all these things, you have this total force acting, and that we have constant of proportionality is 1, so by the proper choice of the units of other factors, that is I, dl and b. So this is the Marie Ampere law. F is equal to I dl cross b, means we are taking dl is the length of magnitude of dl is the length of the conductor, and direction of dl is along the direction in which the conventional current flows through the conductor. If the conductor is having some current, conventional current I, and its length is dl, then dl vector will be directed along the direction of current, and other things are very much clear. Say for example, magnetic field is making 90 degree with the direction of flow of conductor, then in that case sine 90, that is 1. So we have certain force given by that factor. Now more is the value of sine theta, more will be the force acting on the conductor. Lesser is the value of sine theta. For example, if we have a conductor having some current but magnetic field is making 45 degree with the direction of flow of current, then in this case the magnetic field, the force acting on the conductor due to this magnetic field will be 1 by root 2 times less as compared to the previous case. So this is how the variation in force acting on the conductor carrying some current and placed in magnetic field varies with the angle made by the magnetic field with the direction of conductor's current. Now students, we can also find this formula by using the Lorentz formula. You see, we know Lorentz force is, for magnetism we have magnetic Lorentz force is F is equal to Q V cross B. Q is the charge which is moving with V velocity in placed in magnetic field B. Now for velocity we can write displacement by time, and so displacement is dl by t. Charge is moving with some distance, some speed, some velocity, so dl by t. If we replace V by dl by t, you have Lorentz force, magnetic Lorentz force is equal to Q into dl by T into cross B. So here you see, if you take this T over here, you divide Q by T, you get I, means current in the conductor. Therefore we have Lorentz force, magnetic Lorentz force is equal to I into dl cross B. So we are getting the same relation which was empirically derived when we use the Lorentz force. That's all for today. Thank you and have a nice day.